Today, I'm going to be talking about practical machine learning applications using computer vision. So the focus is on computer vision, and it's trying to talk about practical solutions or practical use cases or scenarios where computer vision can be used. Like Kashmita said, I'm a co-founder of Zummit Infolabs. I have about 23 years of experience in the IT industry. I have won state and national awards in software development. I've been an AWS certified solutions architect, Microsoft certified RPA, and all that stuff. I've worked and lived in multiple countries, which gives me a bit of an interesting cross-cultural experience. It's fun. It's good. I've also been a speaker in the Global AI Summit in Singapore on RPA, in Germany, in Canada, and some of those places. So before even getting into the practical aspects of or practical examples of computer vision, let's understand what is computer vision. I'm not going to go into a very detailed definition or explanation of what computer vision is. I'll put it in really, really simple words. It is computer vision is putting labels on visual imagery, right? The imagery or the images can be sequences from a video. It could be from scanners. It could be from phones and cameras or even medical devices. So you see a photo of a cat, it says this is a cat. You see a photo of a dog, it says it's a dog. So all this is around and under computer vision. I have a lot of slides, so I'm going to be moving slightly quick. But yeah, you can note down your questions, post me if you want to talk about anything. So what all can we do with computer vision, right? So if you look at the image on the right, there are these boxes around the dog and objects that you see. There are a green box, a pink box, and an orange box. So object detection and then object recognition to identify that this is a dog, that is a bicycle, this is a car. There's computer vision is used in a lot of video tracking related applications, especially in cars, self-driving cars, or monitoring people, security footage, and many more things. Computer vision also has many, many more areas of applications, like image restoration can be one. Like if you've ever seen your photographs of your grandfathers or parents, that's black and white, old, kind of degrading over time. You could take a picture of that and try to reconstruct or restore it. This is not just enhancement of contrast or increasing the saturation or color or hue. This is actually restoration using artificial intelligence. Right? Scene reconstruction is also a very interesting things coming up these days in machine learning, deep learning. We look at movies like Gladiators, where the Colosseum in the Rome is which is fully broken, is reconstructed. Dinosaurs in movies in Hollywood that you see is all reconstructions of videos and screens. So that's a bit there. How does it actually work, right? So again, not going too deep into the technology aspects, depending on what's your background, but at the core, computer vision is uses deep learning, right? Deep learning is unlike machine learning. Machine learning is all about statistics and inference and numbers, versus deep learning tries to mimic a human behavior. How does a human brain think? It tries to mimic that. When we studied biology, we would have seen the cells and the dendrites and the neurons and electrical signals being passed from one neuron to the other. A neural network in reality is constructed very similar. All right. So what we saw in that video was monitoring. There were unattended baggages. There were dangerous items being carried around by people. There was a nervous person. There was a suspicious person trying to walk around looking left and right. There was a person who was like brushing his hands, and a person walking with a gun. You can see this image. There's Ajmal Kassab was walking with a AK-47 in Mumbai when the terrorist attack happened. And the monitoring those days, I think, was all more human monitored. Imagine trying to monitor 16 different small sub windows in a screen, which has so many different things happening, hundreds of people walking around in public places like airports. Is it really efficient for a human to detect, right? So that's where using computer vision to train, which is trained to detect dangerous objects. For example, a guy pulls out a gun in the airport. The computer vision can really quickly pick up that there is a prohibited item that's in the screen, immediately recognizes it, sends out a message to the security person, and the person who is nearest can take a quick action. and that can prevent casualties. Again, unattended baggages. How many stories have we heard about suitcases with bombs and in trains and metros and airports and restaurants and places? So we have built at Summit. Also, we have built a logic for unattended baggage where a person leaves the bag and starts moving. It immediately detects and makes an alert that that's an unattended baggage, right? So suspicious and nervousness detection, all that we've been doing. That's terrorism and racism detection. Again, has become we all are moving towards equal equality world, trying to be respecting everybody. But then there's still some kind of a discrimination. I would not even call it as racism. It's more of discrimination against age, race, caste, creed, color, gender, ethnicity, any of those, right? So we would like to live in a world where everybody is treated equally, right? Uh, there are certain other issues like privacy and legality, but that's where computer vision has the concept of subject independent emotion detection. That means it can detect a smile, but we can completely make the program not to detect the person. So you would never know who's the person, but you could still tell that the person is smiling, or there's a disgust, or there's a neutral expression. So think about this air hostess greeting a person of a certain gender or age or ethnicity with a nice warm smile and a greeting, and the next person coming in is of a different age, different ethnicity or a race, and there is no greeting. Or even worse, there could be a disgust, a loathing, or if forced to give a smile, sometimes it could be a smile or a fake smile. Computer vision can also be trained to detect fake smile versus genuine or real smiles. That does not mean that we have to start penalizing people to do that. This is more to educate and make people aware that this kind of behavior should go away, and we should start respecting everybody for who, not for their race, color, ethnicity, or anything of that. So again, how does that work? Emotion detection, there are multiple architectures. AlexNet was quite popular. I've implemented using that in the past. There's VGG16, there's more. And again, AlexNet type of architectures are very similar to what we saw in the CNN earlier, convolutional neural network, but it's a very deep, or it's a deep neural network with a lot more layers of convolution and max pooling, and it takes almost 650,000 parameters in the third cycle. And there's a lot of computation. There's a lot of GPU and CPUs to be used to work on emotion detection. But yeah, there are so much of algorithms and solutions in place these days for emotion detection. Any type of emotion like anger, disgust, happiness, sadness, all that can be detected using emotion detection. So that's a bit about the hospitality industry. Let's take a look at manufacturing industry. So again, manufacturing industry is using computer vision quite a bit. Excuse me. So yeah, the primary reason manufacturing companies may be using is for inspection or the quality analysis. There are also other use cases like warehouse guidance systems. So we worked on a project for surface detection, which comes under quality again. It was a very interesting project for bottle caps coming out of the conveyor. We did the analysis, we came up with the architecture. We also trained some data, took some data of paint and scratch and dent on the surfaces of car doors or manufactured products. So manufactured products coming out of a conveyor belt can be very, I mean, it could be very time consuming for a human to pick up a item, check it for paint or scratch or dent and other surface defects, right? So the solution was to put a high-end camera, which the customer already had, and take the feed from the camera and feed it to a neural network, a computer vision-based solution that can be trained to detect whether a product that's coming out of the conveyor belt is defective or not. So the trained model can easily detect and say this lot, this part number was defective, all these parts are good, and it can be humongous amount of time saving and reduction in human intervention, saving cost and everything. So that's a wonderful project, and car doors, scratches, paints for rental cars, even that they're using a very similar solution, which we're looking at. The next use case we'll look at is warehouse guidance. This is a fascinating use case. I'm sure we keep watching movies where there's some uh, illegal activity going on around docks. So you must have seen the container boxes and all. That's where I've always seen, at least in movies, where somebody is exchanging some money or some drug dealers going through or whatever, right? Anyway, so the warehouse management system or guidance system is about nowadays there are more and more guided systems. With computer vision, we can solve the problem of where is an available space, which is the product of the container that can be picked up and placed in the right places. And that can come quite handy and reduce, again, human intervention and goes for optimization. That's a bit about the manufacturing industry. So we will take a look at healthcare. Uh, Hope you guys can guess what would be the most useful healthcare computer vision use case that happened in the last 2 years, 2020, 2021, even now, especially the X-rays and everything. Uh, yeah, COVID-19. Sorry. Yeah. So now with the healthcare industry going more and more digitalized, I mean, there was a time I would go to a hospital, get an X-ray, and wait for 6 hours, or the next day, where they would get the print, and I would collect it from the diagnostics, go to the doctor, take an appointment, and check it. Nowadays, I go to a hospital if I have to get an X-ray. 5 minutes later, the doctor's already watching it on a screen, right? So that's how much digitalized healthcare is getting at. Your MRI scans, X-rays, all are digitalized, which means a lot of image processing and analysis. Uh, Ashmita, how am I doing on time?
think it's 15 minutes time limit, but I think you have just
Okay.
heard.
Sorry, you have more 10 minutes.
Oh, 10 minutes. Thank you. All right. So, COVID-19, that's probably the most used keyword in the last 2 years, right? I mean, everybody has been just talking about COVID, the media, the news, the people, everybody. So, anyway, so the COVID-19, one of the computer vision approach was to just feed a program with COVID positive patients' X-rays and label it as COVID positive patients, and then take a lot of X-rays which are normal, healthy humans, and say these are non-COVID patients. And then the computer vision program or the neural network will understand, saying, okay, so this is what I'm looking for. And then the next time a patient's X-ray is scanned, it would detect and say uh, uh, there is a presence of COVID. The same thing for other lung pulmonary diseases, which can also detect not just the presence of a disease, but also a severity of COVID or the pulmonary disease that we are looking at. So yeah, that's definitely something that we can all relate to, which is pervasive. Everybody is talking about it. There are many more use cases. Another one I can talk about is detecting brain disorder by eyes, retinal scans, and ocular and pupillary responses. Blinkings and image analysis of a human eye can show us whether there is a kind of whether the person is prone to or towards Alzheimer's, dementia, Parkinson's, and similar areas. So one of the projects we are working on at Zummit is, again, cancer and tumor detection. So some of them are related to just any kind of tumors, and one project we're working on is pure play cancer analysis. So MRIs hold a lot of information, and detecting. It's not just about detecting whether somebody is positive or negative about a tumor, but you can actually look at the size and the growth rate and everything else and say, this is stage 1, stage 2, stage 3, curable, non-curable, whether it's malignant or not. A lot of analysis can be done just by training a neural network using computer vision, and make it. It's not like we are going to be replacing doctors ever. It would just make a doctor more. It would give more data, more uh, like a confirmation, or picks up things that a normal human eye may not be able to look at. That would make medical imaging even more better. Yeah. So how does all these work? A quick look of the different architectures available. There's MTCNN, quite popular. Arc Cascade, people have been using it. OpenCV everybody is using it. FaceNet is from Google, so they have their own, logics around it. Then there's DLib, which is also very powerful and quite popular. All these architectures, there's a lot of information. MTCNN, for example, has 3 neural networks called as a proposal network, a refined network, or the output network. It all does similar stuff, but every time it goes through the process, it does more improvements and refinements and gets sharper and better at the outcome. Hard Cascade uses more about a lot of positive images and negative images, tries to tell this is positive, this is negative, and improves the network. FaceNet, like I said, is from Google, and DLib is actually a C++. C++ is probably one of the better technologies to have more accuracy, lesser GPU power, but Python is easier to code, so everybody uses Python. But DLib uses C++, and it uses two different detection methods, SVM-based and the CNN. That's a bit about the architecture. Again, keeping time in mind, I will not go deep into it right now. I'd like to definitely talk about a very interesting and noble project that we are doing called the Third Eye project that we are working with Sprava in Germany. That's the conceptualization is from Sprava. This is actually goggles that is made for visually impaired or blind people. So Sprava, based out of Germany, this goggles is being manufactured in Munich, and we from Zummit are the powering it using the computer vision solution for that. So what does this project do? It can detect objects at runtime, or like what I was talking about earlier using DLib or YOLO or other architectures, object detection. So it can detect if there is a bus in front of you, front of a blind person, it would read out the bus number, like that's bus number 45. And then it can detect currency notes. Like a person is shopping, a blind person is in a shop trying to buy something, opens up the currency note, it says that is a $20 bill. And when the blind person gets the change back, it says that's a $5 bill, right? And it can also detect friendly faces. It says that, hey, Ashmita is in front of me. I can see Praveen Kumar. So it can say it in the audio in the ears. By the goggles is the eye for the blind person. So that's an amazing project. That's a very noble project that we're working on. It's very interesting. We use all latest computer vision techniques, DLib and YOLO and everything else. There are some more use cases. I'm coming to the end of my presentation. Some of the other use cases you can think of is face detection, face recognition. We talked about emotion detection. This can be useful in human resources, like live face detection can be used for attendance. Think about it. No more swiping your card, no more fingerprinting. Just walk to the door. It detects you, opens the door. You're in. Right? That's beautiful, right? That's one of the nice use cases you can think of. We are using in the HR domain for interviews, trying to detect the expressions and emotions of a person. It's not 100% airtight because people are generally nervous when giving an interview. And that's something not we should read into, but there could be, we're not even talking about lie detectors personally, but then the confidence levels can be monitored. Computer vision can be used to observe the other person, see how they're talking, or is it the person who's talking the same as the person who's moving the lips, right? Maybe there's a proxy person sitting behind and giving the answers. You never know, right? So all that and a lot more is there in computer vision. So that's a bit about the use cases that I wanted to talk about. Zummit Infolabs is working on a lot of cutting edge technologies on machine learning and deep learning, RPA, Android, and all. We primarily work on data science based projects for various of these industries. Yeah, that's pretty much about it. And thank you so much.